Hello everyone, myself Amit Kumar Farande from Karmavir Bhaurav Patil College of Engineering and Polytechnic Satara. First of all, I would like to thank Texas Instruments and IEEE for arranging this conference and providing us with this huge platform. Let's start with our project, hydraulic robot arm controlled by human arm.
Can you think if the humanoid hydraulic robot follow your natural action in a far distance? Isn't it an innovative idea? And yes, we have achieved this concept in our project. We got this idea from the animated movie Avatar and Pacific Rim. As shown in Avatar movie, the human action sensing mechanism for controlling the robot. In Pacific Rim and Terminator movie shows the hydraulic concept in robotics. We combine these two concepts in our project. In addition to that, use wireless control to combine these two systems. This project is applicable in all the fields like social, hazardous and supportive system. In social work, we can use this concept for the handicapped peoples, poor needy farmers and needy or injured animals. This system is mostly applicable in hazardous situations like high voltage applications, chemical plant, atomic radiation zone, risky construction lines and anti-fire systems. This concept is also supportive for defense by hydraulic robot armed soldier. We can use them on actual battlefield and control them from control room which is far away from the battlefield. In other way, we can use this concept in disaster management, mining work and underwater applications. Instead of using expensive sensors, we have used simple potentiometer for sensing different human arm action. And instead of using servo and stepper motor, we have used miniature hydraulics in our project. In our system, simple sensing mechanism, no need to train the people, so it is very user friendly. Interfacing of hydraulics with microcontroller wirelessly and moderate power is generated in low cost. Basic theme of our project is divided into the two parts. First is the sensing, controlling and transmitting section. Second one is receiving, decoding and robot arm structure. Let's look implementation in detail. We have used simple sensing mechanism for human action and gave to the microcontroller. Microcontroller output is connected with the encoder. Encoder output given to the transmitting module via multiplexer and transmit through antenna. At receiver side, received signal given to the decoder and decoded output connected with the relay structures and motor driver IC which control further solenoid valve and hydraulic robot arm. Now each block in detail. We used 4 potentiometer for human arm action sensing. These potentiometer are fitted in wooden structure like a human hand. This wooden structure easily fitted with the human arm by using simple wrist belt. When the particular action takes place, then the respective potentiometer shaft get varied, which results in change in output voltage. And this change in analog input voltage is given to the microcontroller. And the output of the microcontroller given to the encoders. Encoder convert this parallel data into the serial form and give to the multiplexer and transmit the signal by selecting each encoder output sequentially. Now complete circuit diagram. We have used 4 500 ohm linear carbon potentiometer for human action sensing. The variable output voltages are given to the ADC of the microcontroller MSP430F6137. We have programmed this controller by using Code Composer Studio. By processing the sensing information, respective control signals are generated by the controller and it is given to the 3H12E parallel to serial encoders, which converts this parallel data into the serial stream, and each encoder stream further connected to the multiplexer IC. MSP430F5137R4 microcontroller select each encoder sequentially and given to the A434 transmitting module, which modulate the data on 433 MHz carrier in ASK modulation and given to the RF amplifier. By using UA741 op-amp, we have amplified the input signal and transmit it by using aerial antenna. At receiver end, receive these signals, decode it and connected them to the relay structure. NO terminal of the relay are further connected with the solenoid wall structure. The solenoid wall structure contains the hydraulic pump, reservoir and solenoid walls. Total 10 solenoid walls are arranged in two parts. First is the pressure side and second one is the suction side. Each side consisting the 5 walls, 3 channel walls, 1 main wall and 1 auxiliary wall. By opening and closing the solenoid wall, maintain the flow of liquid for a certain moment in robot arm. Let's take an example of shoulder movement. When the human hand shoulder movement takes place in upward direction by 10 degree, then the respective control signals are transmitted from the controller, the opening 3 walls at a time, including the hydraulic pump for 1 second. First one is the suction channel number 1, because of suction channel number 1 is connected with the shoulder up down movement in robot arm. Then second wall is main wall and third is pressure auxiliary. The suction takes place in hydraulic cylinder and robot hand goes upward direction in approximately 10 degree. The same reverse action takes place by opening the pressure channel number 1, pressure main wall and auxiliary suction wall, shown in animation. Let's see the hydraulic robot arm structure, which consisting 3 hydraulic cylinder for finger movement, elbow movement and shoulder up down movement. We have used gear DC motor for left right movement of robotic arm by using motor driver IC L293NE. This robot hand made by wooden structure. Let's overview the receiver circuit diagram, which consisting A434 receiver module. This received signal gave to the ST12D serial to parallel decoder. Their output is given to the 8 relays, motor driver IC and hydraulic pump. We have used BC547 transistor used as a relay driver. This relay operated on 12 volt and 24 volt is given to the common terminal because solenoid wall and pump operate on 24 volt. Let us consider the programming flow for connecting the sensing mechanism to the robot arm structure. When human arm sensor sends the analog input to the ADC of the microcontroller, which convert this analog input in digital form and store their value in particular memory location. If the variation takes place in human hand, then change analog input value is converted into the digital form and compare with the previous standard value, which stored in particular memory location. Possibility of results are less than, greater than or equal to. Then respective subroutine is executed and control signals are generated to opening the particular wall, and then restore this new value in previous memory location. The controller continuously check for the change in these values. This algorithm is applicable for all the channels. We have kept 8-bit ADC in auto scanning mode. We have used 2 embedded processors from Texas Instruments, which are MSP430EF6137, MSP430EF5137R4, including 2 analog ICs UA741 and AL293NE motor driver IC. We have built driver circuit, battery level indicator and RF amplifier by using these ICs. We have built up the relay structure and encoder decoder circuit by using non-TIIEC components. We have faced much more difficulties in implementing this new concept. We were unable to interface the hydraulics directly to the microcontroller. Hence, With the help of relay and solenoid valve structure, we overcome this problem. The other difficulty we faced was circular motion. So we used DC gear motor along with the motor driver IC to get the circular motion. And third major problem was wireless communication by using TIIEC EVM board, because an unavailability of setting for 433 MHz, so we use A434 trans receiver module for RF communication. The results of our system are divided into the two sections. First is sensing result and second one is a controlling result. Now we are able to sense 10-degree variation in human hand easily by changing the drop of 130 millivolt approximately. As the degree is varied, the drop is also varied. By carrying out the several field tests, the human arm and the robot arm had variation of 4.38%. The hydraulic pump generates 1.2 bar pressure and 0.4 bar suction pressure for robot arm movement, and also holds 500 gram weight, which having 100 to 200 milliampere current for sensing side and 600 milliampere to 1.2 ampere current for operation of valve and pumps. At last, we conclude that having the simplified sensing mechanism allow to minimizing the cost, use hydraulics for improving the output power, human arm action control the robot arm action, so it is a dynamic, and wireless control explore the area of applications. The limitations we faced are as follows. Use the hydraulics, increase the cost of certain extent. Response time is more for hydraulics than motor. In future, we are planning to reduce these limitations and also planning to use pneumatics in order to increase the accuracy and response in low cost. Interface the video camera and other sensor for improving the performance. For advancement, we can use ARM Cortex processor and EVM from TI for parallel execution and long distance communication. For implementing this new concept, we have referred some IEEE paper and some e-journals given in references.
Once again, I am most thankful to Texas Instruments to providing a platform for presenting our idea, and I on behalf of my team to thankful our principal and faculty member of electronics department.